this fancy pants little Dixie cup, and by fancy pants I mean not at all. It's got. I'm not familiar with Dora and Diego. I'll be completely honest, but I've been told that this is Diego. He's doing some sort of diving with a sea turtle or something, and I put some strings on it because I like to put strings on things, and then I'm going to dump some water in it because that's what cups are for. Okay, and then what I'd like for you to do, as I'm just holding this here, on your paper, because you got your paper out, I'd like everybody to have this paper out and pencil too, is that I'd like you to draw a free body diagram. Here it is. Now, I would like for you to just like keep this simple. We'll assume that this is one string instead of three. It's just really hard to get one string to pull straight up from the top of a cup. I've tried a couple times. It does not work well. So I made it three strings, but we can do this in just one dimension. So you've got just one string pulling this way. Just draw a free body diagram. That's all I'm asking. So we're like jumping back in time, right? It's been a long time since we've done this. A long time since we've drawn these little, simple. I'm holding it right here. Free body diagram of the cup, or the cup and water system. I put some water in the cup because that's what cups do, is hold water. Right? It seems to make sense. Yeah. Milk gets sticky when it gets spilled and stuff. Also a little more expensive than the water that I All right, it's just sitting here. I pretend I'm not moving. I wiggle a little bit. Go ahead and draw that free body diagram. And then once you've done that, check with your table mates. Make sure they agree with you. What's shaking?
Is air resistance negligible?
Yeah. It's also not moving, so there's that. but yes, we will ignore air resistance. Did you draw a picture? No, you're drawing a picture right now. Don't overthink it, right? Like, this is really, we do not need to overthink this. All right. So, all right, we're just going to make it one string. Do you guys need whiteboards for this, or do you agree? Did everybody agree? Yeah. Jonathan, how many forces do you have acting on your cup water system? You have two? What are the two forces you have acting?
I have the force of the earth on my cup and the force of the string on the cup.
Okay, and which way is the force of the earth on the cup acting? It's acting down because, it usually does, doesn't it? So that's the force of the earth on, I'm going to call it the system. Is that okay? The cup and water together. Sometimes people get really crabby about whether it's the cup or the water and whatever. I'm just going to call it the system of the cup and the water. And because some of us are lazy, we're going to write that as FG. So you got that. And then what was the other one you said? I'm sorry. The force of the string. Which way is that one going? It's going up, right? That kind of makes sense. Sure it does. I don't know who's making that beeping, but if it's you, can you stop, please? So the force of the string on the system. And if we're lazy, instead of writing that out every time, what are we going to write that as? Oh, I like it. Okay. Fantastic. All right. Now, question for you. As those two things are sitting there, how do these forces compare? Equal in magnitude, opposite in direction. We know that they have to add up to. I love it. Look at you guys. You are so smart. All right, Harrison, I was totally going to pick on somebody else, but you're wearing the goggles, so I can't resist. Come on up.
Why is this face on?
Did you keep the goggles on?
Yes, of course, because if you don't have the goggles, then you're just a random kid.
Yeah.
All right, lay down.
Yeah. Like, on my stomach or on my back?
On your back. Okay, that's beautiful. Okay, good work. Right, I know, right? So you're just going to lay down there. Okay. I heard some people making predictions back there. It's not my intention. Gunnar, what am I doing?
Goggles on.
Right, that's why he has the goggles. That's why.
Gonna spin it.
Yeah. What are we doing? We're going to spin it, right?
Okay.
Do you want to come up, Kate? Come on, Kate. You come to. Yeah. Come on.
Trust exercise.
It's good. I've only been doing this for like a decade. Come lay next to me. There you go. There you go. Shoot together though, because I can't. Yeah, there you go. All right, we're all set. All right, you ready? Here we go, team. You ready? Okay, you don't trust me. Oh, come on.
They have to make a jump.
All right.
That's all it's gonna be.
Trimester 3, right here.
Hands are getting sweaty. We all on tag.
Are you ready? If you want to stand up so you can see, you can come on up here. That's okay. All right, here we go. You guys ready? Hey! Isaac, do you have some goggles you can let her borrow? Did you bring goggles today?
No.
Oh, great. She'll be all right. All right. Okay, here we go. Here we go, team. All right. A little nervous every time I do this. Just a little nervous. Okay. Here we go. Whee! Did you get wet?
No.
Is it because I didn't do it well enough? I didn't do it very long, did I? Should I do it one more time? One more time. Here we go. You're still okay? Yeah? Don't say bad words. Otherwise, I'm going to start throwing you out of the room. Here we go. Whee!
Break.
Life is good, yeah? Did you get wet?
No.
Watch your mouth, my friend. Be careful there. All right, go sit down. You got it. You saw it. Now, Kate, you were safe, right? You got it. It is a trust exercise. Do you trust your physics teacher? That's the question. Right? Not with me. Like, it's all good. Now, this is what I would like for you to do, my friend. Because we saw it, and if you don't trust me, and sometimes apparently did I tell you guys that my regular physics kids don't trust me, like they think that I lie to them all the time now? Like they're like,
Momentum.
I know, that's where it came from. And I'm like, darn it, like I totally lost it. Anyway, regardless, it doesn't matter. Kate, did you get wet?
No, man.
Harrison, did you get wet?
I don't know. I wouldn't have felt it because I was wearing goggles.
Well, so your eyes didn't get wet. Did the rest of your body get wet? Okay, so you're all right. So now, what I would like for you to do, friends, is next to your picture that you already drew, we can draw this thing as a big circle, right? So at the top, here we go. Here's my string going up to the top, and then here's my cup water system at the top. So it went around in a big circle, right? So like this and like that. What I would like you to do right now is to draw a free body diagram of the cup water system when it's up here. Okay? Free body diagram. Do it, my friends. You got this. Stop. Just do it. Do it. Boards. Let me see your boards.
Upside down?
Oh, it's just
Oh, fun. You didn't do that.
there are no forces.
I'm
FT.
Googling it.
I got this.
Make sure gravity goes up.
Let me see your boards. Let me see them.
It's
Everybody
two
else
words.
got it wrong. We got it for the space.
That's not supposed to be that big.
Ian, can I see your board? Okay. So you can put your boards down for a minute. I want to have a conversation with you about this to make sure that we are doing physics with fidelity. We're doing physics and we're thinking about what it means to do physics, right? We have talked about forces for a long time. We have talked about forces and we know that every force has to be an interaction between how many objects?
At least
Two. Only two.
Oh.
Only two. It's an interaction between two objects. And you need to be able to describe them, right? So the kinds of forces that we talked about, and this is going way back, friends. We talked about gravitational forces. That's a force between any two objects with mass. We whispered about this electrostatic or electromagnetic force, which we know nothing about yet.
Yeah.
Just wait. Later this unit we'll get to talk about it. We mentioned or whispered, or maybe I didn't even say the words strong force or weak force. What are those? We don't care. I mean, like, we care, but we don't care.
Chemist cares.
Okay. Well, physicists care a lot. Physicists are the one that actually do it, but we're not going to do it in here today. So, besides those forces, everything else has to be contact forces, right? Contact forces are really just the electromagnetic forces. Don't tell. Okay? Okay? So right now, in our repertoire of forces, we've got gravity, which is the force of the earth on something, right? And then anything else has to be a contact, right? It has two things touching. A tension force is a touching force, right? So what have you got? What forces do you know? What's acting on this cup water system?
Gravity.
You know that gravity's acting, and I'm going to ask anybody but Henry right now, which way is the Earth pulling on the cup water system? Down. Because it always pulls towards the center of the Earth, right? Center of mass to center of mass. That's how the gravitational force works. So you've got a gravitational force pulling down. So that's the force of the Earth.
Well, what if swinging the cup summons mass the size of the Earth above it?
It does not. Because if that were the case, I mean, if we were going to live in this weird supposition of a world that you are suggesting, a lot of other weird things would happen and we would not be here to have this conversation. Making sense? So, what else you got? Tension. Which way does tension pull or push, friends? It has to be down. Because it always pulls, what did you say, Ian? Always it pulls along the rope. Sure it does. So it's got to go. What color did I use before? Pink? Okay, Isaac, what did you just say? Because I heard you say something. You were a little crabby about it maybe, but I'm not sure what you said. What did you say?
Me?
Yeah, didn't you say
She
something?
said your name.
No.
I thought I heard you say, as I was writing that, you said something. No?
Probably not.
Probably wasn't intelligent.
No, it was. That's why I'm asking, because I thought I heard something that was the step that I wanted next.
I don't know. Forget it.
Okay, well, I'll back up and it'll come to you.
I forget.
What else is acting? What else is acting?
You.
So is it my mass? Are you talking about my gravitational force pulling on the system?
Well, yeah, a little bit.
Not enough to matter. We'll calculate that in a week. Not enough to matter. Am I touching the cup?
No.
The cup water system? I'm not. Now, was I helping it to move? Sure, but I was touching the what? The string. So if I was drawing a free body diagram of the string, then sure I could draw my applied force. But am I touching the cup water system?
No.
I am not. So I don't count in this case. Right? What else is acting on the system? We're assuming no air resistance. What else is acting on the system, friends?
Angular velocity.
Remember, every force has to be an interaction between how many objects?
Two objects.
Two, and it has to be two, right?
Right.
So it's got to be either a contact force or a gravitational force. We've already got gravity.
Yep.
What else is touching the cup water system?
The air.
We've already gone over it.
What'd you say, Jacob? There's nothing.
It's a trick question. Oh, come on.
So now, when I swing this cup and I put it up here, right? I did that kind of on purpose, right?
Proof that physics doesn't exist.
What should happen to the cup? What should happen to the water?
What?
You with me there?
No.
If I put the cup of the water up here,
Oh.
there went a drip, then it should fall down, right? If you look at the net force of this system, the net force of this system is in what direction?
So gravity has to be going up.
Down.
You want it to be going up, don't you? You want it to. You're like, doesn't make sense. Why is the water not falling out? Because the water did not fall out onto you guys, right?
Because it's spinning.
I don't think so.
Besides,
Courtney, what did you just say?
New form of anti-gravity water discovered.
Wrong answer. Courtney, what did you just say?
Because it's spinning.
It has to do with the fact that it's spinning. If I just take that water in that cup and I actually put water in here, and I had Harrison lay down here with his goggles, he'd need his goggles on, wouldn't he? Because if I put it like this, the water's just going to go straight down.
It's down faster.
Okay? Magic cup. No, that doesn't work. That doesn't work. But the fact that I'm spinning it changes the situation. The fact that I'm spinning it changes the situation. I want you to think way back to Newton's first and second law. Do you remember what Newton's first and second law was?
That if force net is equal to 0.
Prokaryotes were not by other prokaryotes, thus created endosin by a high force.
Yes, the force of that is not equal to 0. The acceleration is not equal to 0. Thank you. I knew it.
All right.
You knew it.
High five. All right. This is one of those rare moments when I'm like channeling Henry because he's the person that's like got that, and everyone else like yes, I gotcha. All right, here we go. This is right here. This is it. If the net force is 0, acceleration is 0. You probably don't, but you might want to if you could. Now the deal is here that if F net isn't 0, then the acceleration isn't 0. Let's think about the water just for a second, just the water itself. At this moment, as the cup and water are going around and around and around, at this very moment, think about this in terms of the horse or the lion on the carousel. What direction is that water going, friends?
With the cup.
What direction? In exactly which direction? That direction, right? The water is moving in this direction. It's got tangential velocity in this direction. If there is no net force acting, if F net is 0, where is that water going to go?
Down.
If there is no, no.
Yeah.
This is where it's like step out of the box for a second. If the net force on this water is 0, where's it going to go? It's going to go this way. It's just going to go straight line.
I don't. Wait.
Keep talking. Come here.
If you don't, if the F net is 0 on it, then what? It's why?
If F net is 0, acceleration is 0, it's just going to keep going a straight line. It wouldn't accelerate.
On the, like, when it's already going this way?
Yeah.
You don't.
The fact that you've got, this is the thing, you guys. The fact that you've got these two forces acting is what keeps the water in the cup. Otherwise, the water would just go straight this way. Okay? I'll see you tomorrow. Have a great day.